Here's your web page. Here's your packet. Here's your payload that you asked. You're good. You did the right thing, and I did the right thing, and we're all okay. This is opening the door and saying, hello, come on in. You know. Redirects. Now, this may be what you do when a salesperson comes up to your door and you say, you know, go away, I don't want any. You know. There's a variety of different ways that a server can tell a client, hey, you need to go somewhere else. Move permanently will come generally with another address so that you can then say, oh, you know, my Google is now pointed at this site over here, so I should go there.
Bing.
No, I'm kidding.
Nice.
Yeah, maybe.
302, this is often a misused as well because people will use 302 in place of 301. And ultimately it's there to say, I know what you're looking for and it really is over here, let me go get it for you and then try and route it through. Okay, there's so many 400 error codes, I'm not going to get to them because I really don't want to bore you, I promise. Are you bored yet?
Just get to the good ones.
I'm working on it.
The funny one.
Dude, I got to ratchet up to this thing, you know? If I start off with the fun shit, then it's over. You know? This is the warm-up act. I got to warm up to my own act. All right. Bad request. So if you try to talk to a web server and you make a request that doesn't really look like what it's expecting to, like, you know, you make a post instead of a get, you make a put instead of a post, something like that. A web server should tell you bad request 400. What you also then see more commonly in TLS negotiations is the unauthorized. What usually happens is in a handshake negotiation, client will say, hey, I'd like to talk to you. The server will say, unauthorized, don't talk to me without SSL. And then the response returns with a SSL token, and then you can say 200 OK, and you start talking again. That's the what's the secret password thing that you whisper through your door. Okay. And then if somebody gets the wrong password, then you tell them to F off, and you say 403 forbidden. Yeah. If you try to load a page that you really shouldn't access, you know, if you try to access that S3 bucket that you really don't have access to, this is what you should be getting. Now, a bit about what you should be getting. This is a spec. This is a protocol, which means these are clearly defined rules from a big consortium of nerds that get together and say, here's how the web should work. Generally, when people write web servers, they may use 3 to 5 of these and not code a response for every web service, for every status code in the books. I'm not implementing WebDAV. You implement WebDAV. Yeah. How many of you seen a classic 404 not found?
Yeah.
Yes. Right. That's there to say, hey, you made a proper request, but to a destination that doesn't exist anymore or ever. So I don't know where it is. Sorry. Too bad. Go away. Oh, I put this here still? All right. Now again, method not allowed. This is again like, hey, you tried to put when you should have post. You tried to get when you should have post or put or something like that. All right.
Wait. No 418?
We'll get there.
Okay. You like left the 400s. Like,
Oh, I just want to get through some of the buckets, and then I got, like I said, I'm the warm-up act.
I gotcha.
Yes.
Are you going to sing a song? When you
Yeah, are you going to
Now.
sing the song? We can all sing the song, too.
The song.
Do I look like I'm choreographed?
Yes.
We'll get up there with it.
Here, which one was that?
Common one.
Bad request.
Bad request.
There we go. All right. Now, the classic thing that something went wrong inside your program on the server side is the 500, internal server error. 500 class of errors is for stuff when you did everything right, but I did something wrong. When you get 500, that's what you should be returning to say, hey, I had a stack trace. Hey, I had an error. Hey, I barfed up. I did something wrong. Hey, there's a cat stuck in my server and it doesn't know how to respond to you. Because it's a cat.
Are you sure it's not a hamster?
Yeah. You will also run into things like bad gateway. This is generally stuff that's more on the perimeter because your application may be behind like an Nginx server or a F5 load balancer. Those things throw 502s to say, no. you're not talking to me correctly, go away. You can throw 503 to say, you know, the back end's down, sorry, I can't help you. You know, my cat's in there instead of my application, sorry. All right, now what you've been waiting for.
Yay.
Okay, now mind you, I love HTTP cat because it's a light and humorous way to look at something boring, like status codes. All right, so we're gonna work through the numbers again. So the 100s, this gets back to the whole idea that there may have been more setup involved in trying to talk to your server. This was considered back in the day of like early DSL and 56K baud modems. So you may try to load your Alta Vista page and it may take 30 seconds to respond. So the server can then say, hold on, hang on, it's coming. Oh wait, you gotta talk over here, but it's coming, I promise you. So that's what a lot of these other 100 series status codes are there to do. All right. Similarly too, your 200 status codes are there to kind of help provide nuanced information along those ways. They're still lesser used today, again, because network communications are so much faster. You don't have to say, hey, I got your request in the process of building the request. It's much faster, just throw a web page over. But that's often what you get with like a 202. You know, or a 203 to say, hey, you know, while you're at it, just know you're on a government site, so we're going to shove some government stuff in your headers, things like that. All right. Similarly, too, in old times, there used to be the ability to look at things like real media players, where you could watch really grainy, horrible videos that were moving very slow over the internet. So, of course, you might get part of an image, hence partial content, but you know you weren't getting the whole thing. Now, a lot of that kind of use case went away with things like having a content length header, so that way when you get a payload back and you know it's supposed to be so many bytes long, you can check it and say, cool, I got everything. All right. Or, oh wait, I was starting to stream a little image over this very slow internet connection. Everything had to start over because somebody rebooted me. What's going on? It's kind of interesting. All this stuff is still part of the spec. Remember, we're talking early mid-90s protocol drafting that's still in use today in 2024. So many of these, they're well-defined, but never used. You know, like this one. You know, how often are you then going to get a request back that changes the state in flight? Because things go fast, you know? All right, so up to the 300s, you know. We talked about the 301 and the 302. The 303 is more of a confusion state about like, yeah, you're not here, but I'm not sure where you are, and I'm not going to give you a 404, so I'll send you over there. 304 was an efficiency mode to say, yeah, you requested something and it hasn't changed. Go away. Use what you already have in cache. Yeah. People use 301 and 302 when they really should be using 307 and 308, temporary and permanent redirect. This is useful. This is accurate to a situation, say, where you have 100 web servers and one goes down because it's being restarted or because there's a cat in the server. Then the server might have something in the front of it that says, oh, wait, I can't talk. Let's 307 you over to the neighbor. Something like that. All right, so we talked about, you know, you can't eat cats if you're a former president. And no, I'm not going to go take a bath. These were more precise error codes for things like, you know, you're talking to me in the wrong way. You're asking for a method that you can't do. You're sending me a payload that I don't want. You know, go away. Come on. All right. There's also specific error codes for proxy communications. Who knows what a proxy is? Okay. All right, Whit. What's proxy? Tell us.
Oh, you're gonna embarrass me. So it's.
Oh, I was actually talking about you. Please go for it, because I don't want to hear from him.
It's a service acting on behalf of somebody else.
It's a service acting on behalf of something else. Exactly. Great. Cool. So proxies have their own. Yeah, they have their own sets of protocols to be able to say, hey, before you can talk to me, you have to talk through the proxy. And the proxy may require auth. So that's what that's about. Is this what you were looking for?
Yes.
Yes.
I do the dance.
Yeah.
All right. This is to show that engineers are not without humor. This came up during the drafting. They were writing this as an April Fool's prank, and it stuck because people are nerds and we love our jokes. Speaking of jokes, not officially part of the HTTP spec, but the kids at Twitter, long before I ever worked there, they came up with 420 to avoid thundering herd scenarios. So you basically get this while you're getting the fail whale, if you remember what the fail whale was. All right. Who does not know what the fail whale is? And would like, okay, cool. Bit of Twitter arcana history. Twitter was not always a robust and stable platform. It's not. It was and now it's not. But before it was also was not. Wow, this is like time travel prepositions. So
I've seen the fail must, right?
So what would happen is the people would send too many requests. Like your favorite team won the Super Bowl, or the latest Justin Bieber video dropped back in those days when he was more popular. Yeah, or Britney Spears would just tweet, or Ashton Kutcher would just tweet, whatever.
New Year's in Japan.
New Year's in Japan. Oh, we hated New Year's in Japan.
Sorry.
That's another story I'll tell you offline. But when all those thundering herds requests would come through, not only would Twitter throw the fail whale to say, oh no, I can't handle all this, but the status code they'd throw enhance your calm, saying, chill the hell down. Let's just stop retrying, because this is like a way to say, you're thundering herding my site right now and I can't handle you.
Did the Twitter client actually do something special with that code?
To my knowledge, no. I think we just returned the fail whale and did this. And I think this was a short-lived thing anyway.
Okay.
Yeah. So that's all I got on that.
How many servers did Twitter originally run on when it was first launched?
I don't remember, but I remember hearing. It was like shockingly small number of servers. I remember hearing this talk like during my first week there during orientation, but I don't remember the details. It was very small. They were like running it out of a single rack in a data center. And
Yeah, I think it was like in the rack with Odeo, right?
Single MySQL server.
Right. Every site starts off small like that. You don't immediately take up an entire data center. Now you just, throw a giant pile of garbage into DigitalOcean. And you do that because Heroku doesn't exist anymore.
Just run it off your laptop in Ngrok. Works great.
There you go.
Jokes aside, I actually did that when I was a teenager and didn't have any money.
What, ran a web server off your laptop?
Yeah, my dying laptop.
And then you shut it down every time you close your laptop to go somewhere?
No,
And then your users would be angry?
It was my dying laptop, so it stayed at home all the time.
Okay. All right, so there's my attempt at a fun talk about a very boring subject. Any questions? Yes, Rich.
I have a really bad pun to set up this.
I said questions. 400, bad request. No, go ahead.
I want to know the rest of the story. So when we were writing REST APIs in like the early 2000s, mid 2000s, we would use all of these things egregiously, right?
Yeah.
All of these codes. But do people even write REST anymore? Do people care about APIs?
Yeah, people write REST,
They care a lot.
but people don't necessarily exhaustively code for every status code out there.
Yeah, we kind of pick the ones that work for
We
the
pick,
situation.
yeah,
The ones that
like
communicate
in
with
general, you maybe need like, you need to handle some 500, you need to handle some 400. You let an SSL library in front of it handle your 401 unauthorized and 403 forbidden.
Yeah.
Your 404, you have a default web page. You might 301 or so if you have like a load shedding algorithm going on to say, hey, I got too much, let's send it off to a less occupied server. And then nobody's ever going to do anything other than 200 for a status code in the 200
Unless you're
series.
Google.
Unless you're Google.
Well, can't additional information be used as a vulnerability? So, hey, I say use a proxy. Well, now any malicious attacker knows that to communicate with this endpoint, you have to go through a proxy, so they can start looking for a proxy or a way to spoof that. So a lot of times you'll get a 400 or a 404 when there's a more specific status code that you could have received,
Yes.
but least information possible.
That's an interesting thought, you know. And
Yeah.
I mean, on one side of that, you use a proxy because you have a proxy that is more secure. So it's like, go ahead and try, but we have a proxy. Right.
Yeah.
I saw a hand way back there.
That pretty much covers it.
Okay, cool.
So going back to my security groups week last week around AWS, last month around AWS, your direct recipients from your load balancers and your proxy should not be exposed to where they've given out those codes. They should just return essentially a send and no response.
Right. You might have more robust status codes for internal server-to-server comms.
Yeah.
But even at Twitter, where we had literal hundreds of thousands of microservices running on hundreds of thousands of hosts, they really only used like those 5 to 7 status codes at the end of the day. You know.
It makes sense. It's like, why would you want to change the way you said things all the time?
Right.
As you scale, that just increases the complexity.
Right. Lori.
Kind of follow-up comment to all that of like, you know, with not giving a specific of status codes, it kind of depends on like what you're running and why and who's accessing it. I only run very secure stuff that only people we have designated should have any access to. Anybody else, I don't want to help them. I'm going to give them a very generic error, and that's that. I don't care about those people, because if someone actually needs access into like my stuff, be it on, you know, HTTPS, they're like in a web portal, because I manage a few web portals for like secure file transfers or, you know, like SFTP kind of stuff. They've already had communication with me individually, like over email, and so if they get an error, I want them to contact me through that secure channel. I don't want them to try to figure it out on their side. Like, we need to get on a call and figure it out. So it kind of depends on like, but if you have something that is for the general public, yeah, you might want to like give more detail. Just depends on like what you're running.
It's like the difference between telling your neighbor where your spare key is so that they can get in the house in an emergency, and not answering the door for anybody you don't know. You'd rather they not know whether you're home or not. You'd rather they know nothing.
Yeah.
I think there's a reckoning coming too with the status codes. There's going to be a lot of those deprecated.
Well, like I said at the beginning, 2.0 abandons many of the status codes just because the protocol is designed to be absorptive of different issues. You know, it's meant to be able to send packets just in chunks, and the chunks have their own protocol.
I would say to a certain extent on the other side, it can be useful for internal logs and that sort of thing, just to see more of that granularity as
Exactly.
far as like what came in, looking at that. So maybe less useful for the responsibility person coming in, more useful for the internal team.
Exactly, yeah.
And then a lot of things that are calling REST APIs really only care, is this in range 200? If not, we failed and handle some failure case.
Yeah.
We don't really care why the server failed, you know.
As a predominantly third-party integrator to stuff, status codes are everywhere. They don't go away.
Yeah.
When you're hooking into a company's internal API or something of that nature, they use them a lot. They're actually really useful to actually know, hey, do I need to get on a call, or did I draft this wrong, or things like that.
Yeah.
So at least for content management systems, things like that that are designed to have internal APIs, it's best when they are really robust.
Right. And it's all about use case. Remember, again, there's the protocol, which is like all the rules defined, and then the actual code that you write at the end of the day. You know, I'm thinking now about like a conversation I was just having with somebody recently. I didn't study comp sci in college. I studied like management shit. So I could not tell you about specific algorithms. You asked me to tell you the difference between quicksort and bubble sort, and I'll shrug. But I know how to look at code and say, yeah, that's an unnecessary loop, and I know how to move things around. You know, because, you know, I don't need the specificity of the rules to be able to know how to do things. And that's often what happens at the end of the day. We shove more information, we hopefully shove more information into usable error messages that you can filter through in order to find out what's going on with your inability to communicate. So, there you go.
Yeah,
All right.
it's a use the right tool for the job kind of thing, Mr. Natural would say.
All right, cool. So, was this boring?
No.
Awesome. Cool. I just read to you the most boring shit in the world, and you didn't think it was boring. So, cool. I'll take that. All right. Thank you. So we'll let's take like 15-ish minutes and grab another taco, grab an Oreo, use the restroom, whatever. Yeah. Because we got a much better talk coming up.
What's the challenge?
There was no 418. I was like, what?
That's the one.
Beej, are you going to do your presentation again?
Grab it. I knew if I put it up early, it would be over.
Yeah.
That
was good.
Yeah.
So, are you good with casting?
I think so.
Okay. Are you doing? How are your slides? That's okay.
We'll be in the next
Well, we have an Apple TV set up here. So maybe like, yeah. Yeah. You did? You don't remember? Maybe you were not.
I'm just kind of like, honestly, maybe I was.
Well then, are you forgetful or not? I actually dug up my life. Share.
I've got an extension. Oh,
Yeah.
is that power right there? That's power, right?
Yep.
Yeah, that'll totally work.
Yeah, and I'm not like sitting here reading the RC all day.
Lily shutters the
We're always looking for speakers. How do we get to the Apple TV?
Oh, yeah, live here.
Did you do it?
The Apple TV is plugged in.
You know the rent is for the so it certainly is.
If I have to, I can go straight to it. Well, I don't know if it's
I got stuck with that like
Don't worry.
Let's see.
That doesn't mean I can work AV shit at all.
I really like this.
Alright, as far as this is gonna get, I don't know if there's anything that we can do to make it better.
And I'm supposed to be standing over here?
So, yeah.
Just stay till
Okay.
Yeah, so if you keep moving left, I'll tell you when you're too far. Keep going, keep going. So that's where you're out of screen. And then if you keep going all the way to the other side, it's gonna be like right over here. So I think.
But I won't want to get in the way. So.
Yeah, exactly. So like right in there. Next time we'll do like tape. We'll have the wall stands.
Okay.
Cool. Alright, cool. Something.
Yeah, but
actually,
I'm just being honest. I can't remember. It doesn't make it what she asked, but you don't even have to pat your pink side eye. I just said no,
I was on yes early, and I didn't want to start in practice. Okay, everyone. Hey. All right, so that was a great talk by Brian. I guess he likes to call himself Boring Brian for whatever reason.
Brian's talking now.
Yeah, so now we got another Brian who's going to talk to us. And apparently he's the more exciting one.
Let's flip back in.
That's a hard act to follow. I'm not more excited than that.
What?
I don't have. I mean, this is freaking Vim. There are no pictures of cats.
We got Rust overview though. Like, come on.
Well,
Brian here says that this is the exciting one, so we'll go with that. The floor is now yours.
Thank you, thank you.
Holy shit, that looks like a live demo.
Yeah, it's gonna happen.
He's got the cursor blinking.
So, hey everybody, I'm Brian. My nickname is Beej. I have a completely fabricated entire name that was given to me by other people ages ago. If you just Google for Brian Hall, you're gonna get a lot of matches, but if you Google for Beej Jorgensen, I'm pretty sure I'm the only one on the planet. So, that makes me quite neat. So I'm an instructor at OSU Cascades. Hi everybody. And I managed to coax some of my students to come to the presentation, which is nice. I've also written a bunch of programming guides, Beej's guide to various things. The one that has the most attraction is Beej's Guide to Network Programming.
Oh man, that's been around for like 20 years, hasn't it?
Yeah.
I remember reading that. Like,
It's been around since
that's so funny.
1995. So, yeah, I guess it's...
In the flesh.
Yeah. So, this is my one person I claim to fame.
It's like every time you know how to do something with a socket and C, that's what people look up.
Yep.
Wait, that was you?
That was me, yeah.
I have that book.
Anyway, today I want to talk about Rust a little bit. So this is going to be a little bit programming heavy, so if you're not into the code part, I'm sorry ahead of time. But I want to talk about Rust, the language, and my awesome Vim slides, and a little bit more about the Rust ecosystem. So there's a package manager, then I want to talk about some of the features of Rust that make it unique and difficult, and also I want to talk about, finally, using Rust as a web server, using a web framework called Actix. So there's going to be a bunch of stuff at the beginning about Rust, and then at the very end, we'll throw together a couple lines of code and get a web server going, and we can see how that works. So that turns out to be this turns out to be the small part of it all, and the rest of it, I'm hoping to whet your appetite with some of the idiosyncrasies of this language. That's, I think, for maybe 3 years running or something, it's been like the most loved language in, is it the Stack Overflow survey, yeah. That doesn't mean it's the most used language at all, but it is the most loved. So a quick note on getting help. If you're going to Google for Rust, good luck, but everybody says Rust lang, and that's what you're going to tag your searches with if you want to find anything. So what do we got here? What about this language? It's compiled, it's strongly typed, it has generics and all the other stuff you might imagine in a modern language.
Wait, Golang doesn't have generics.
It does now. They added it. Finally, after so much kicking and screaming, they added it. But this is the big claim to fame for Rust. It has safe and automatic memory management, and it doesn't use a garbage collector. So in a language like Go, every so often, the garbage collector comes to life, looks for unused objects, and frees them up. And this takes a little bit of time. There's a tiny little spike in CPU when this happens. And so the people who designed Rust thought, can we get away from this? Is it possible to have automatic memory management? No dangling pointers, no use after free errors. Is it possible to do this without a garbage collector and without needing to do manual memory management? And yes, it's possible. We'll get to how it's possible in just a second, but it's not exactly pain-free. There's a bit of a learning curve. A quick note on installing. Your operating system is going to have some package manager that you can install it with, but you can also use Rust Up, which is a really common way of keeping your Rust installation up to date. So you can Google for Rust Up. There's a quick shell script that you can get from curl and run without looking at it. I'm sure it's safe, and then it'll install this, and you can keep a Rust install up to date. So here's Hello World. Not much to it. We've got our main function, print line with an exclamation point. That all means something, but don't worry about the details. Here's how we can build it. once you have Rust installed, there's the Rust C compiler, and you build that thing up and run it. I'm not going to demo that directly. I'm going to use Cargo instead. So Cargo is a package manager. There are all kinds of Rust packages that have been built by people that you can use to do all kinds of things. You can use Cargo to install them. You can also use Cargo to create new projects. And you can also use Cargo to run your projects and build them and make release builds and make debug builds. So it does quite a bit of stuff. And a lot of people never run Rust C ever. They just run everything through Cargo. And so I want to demo that right now. Let's actually jump over to this window and make something new. Bigger.
While you're doing this, I just want to point out, if you're using a Mac and you're using Brew, you can install the Rust up init through Brew.
Aha. Which is probably safer. But
Brew? No. It's written in Ruby. No.
Shade cast.
So it all reaches down to Perl at some point, so.
So here I've made a new project. If I have a look here, I see this hello directory, so let's take a look in here. And there are a couple files already. Actually, let's do this. And, well, that's weird. I thought I was going to make this a Git repo. It did it on the Linux machine. But it didn't do it here. That's okay. I was about to say it's going to be a Git repo already, but it's not. So I've got this cargo.toml file, and then we've got a source directory, and it's built a main.rs for us already. And if we look at it, it's got a hello world. So when you make a new cargo project, it makes a hello world for you. And I can run that with cargo run, and it'll compile it and give us the output. So that's basically how to make a hello world with Cargo, the package manager. And it's a Git repo already. No, it's not.
Might be.
It might be. I swear I saw that
Mine
happen.
turned into a Git repo.
Schrodinger's Git repo.
Yeah. So let's take a step back here and talk about this whole automatic memory management thing and how that can possibly work. Like, how can we have all these objects floating around and that be managed without a garbage collector? And it's actually really simple. And that simplicity you'll love immediately, and then you will hate it with a passion, and then eventually you might come to love it again a little bit, maybe. We'll see. But this is how you do it. If you have one object, you have a variable that refers to that object. Just one variable can refer to an object at once. That's all. And so when that variable goes out of scope, you free the object, because you only had one reference to it. A lot of the reason a garbage collector has to exist is because you might have multiple references to the same object. And one of those references going out of scope isn't enough information to free the object. You have to know when all the references have gone out of scope. But in this case, if you only have one reference to any particular object, then great. As soon as that reference goes out of scope, then we free up the object. And that's it. I have a little note here that there are certain other higher level objects, and that we could borrow objects temporarily to help ease some of this pain, but more on that in a second. And if you're into data structures, at this point you might be thinking, I can only have one reference to an object. Like, how is a graph data structure going to even work, where you might have different references pointing to all kinds of stuff? It works kind of painfully. It's not super ergonomic in this language. Can be done.
Not language for DAGs.
It's Turing complete, so you can do it, right? You can.
That's why you do it in Java.
Yeah, so it can be a little painful, but let's take a look and see what happens with some of these things. So I'm just going to live demo this because it will, if I can type this all right out of memory. Let's edit our main here, and I'm going to make a new variable, and I'm going to hand wave over what string from is all about, but I'm making a new string variable here. So I've got that variable, and I should be able to print that thing out. So S is hello world. Great. And if this were any other language, we should be able to do this. You know, T is assigned to S, and we should be able to print that out. T is T. Let's make sure we're still in business here. Great. Question is, what's S after all this? I don't know. Let's print it again, see what happens. Uh-oh. Trouble brewing. Let's see if I can get a bigger screen here and run that again. Whoops. Okay, all kinds of fun stuff. Borrowed moved value S. Oh, so there's a lot of stuff going on here. One thing that's nice about this compiler is that it gives colorized ASCII art error messages describing what's gone wrong. And anybody who's looked at 400 million pages of C++ template error messages pouring out of your project, this is kind of a relief. But at the same time, we're looking at this and it's, I mean, what the hell is it talking about? What is any of this stuff? The move occurred here because SS type strings did not implement the copy trait. The value moved here. The value is borrowed here after the move. Note, some eye glazing stuff, and then there's a suggestion here, consider cloning the value. Let T equals S dot clone. All right. So what we've done here is we've violated that rule of there can only be one owner of an object. And so if I look back at the code that we have here, we have this situation where S is the owner of that string object, and we print it out, and right here ownership transfers. So the value moves from S to T. At this point, S is no longer the owner of that thing. We can't use it anymore for that thing. T is now the owner. And so it's perfectly happy doing this. Sure, print that out. But if we want to print out S again, bad news. S is no longer a valid reference to that object.
So what is S at that point?
Actually, it's a good answer to that question. It's like it's a symbol, but it doesn't.
It's an undefined symbol that the compiler won't let you access.
Yeah.
Right.
Yeah.
Sorry.
So you're using specifically string from though because it creates an object. But what if you were to just have a bare string? Would the same event happen?
So no, I'm actually going to demo that slightly differently, but
Okay.
I'm pretty sure no. I didn't try that. But that makes a reference to a static read-only object, so I don't know.
Right.
I don't know how that works exactly.
Just a curiosity, because that makes you, this
Make it a
kind
slide.
of thing makes me wonder what single equals is really doing.
String references are copy. So
String
it should
references
work.
are copy?
Yeah,
So it should be fine.
It does work,
All right.
or at least on my machine.
I was going to demo
Dangerous words.
Yeah.
There we go.
Oh, and there's an extra S.
Well, I printed it out 3 times, so.
Yeah.
So I was going to demo this with a number, like an integer, but this demo also works well with just this string reference. So I kind of didn't want to get into this. I'm not going to actually, but strings in Rust are kind of an interesting thing. There's these string references, string slices, owned strings. There's a chapter in the book about it. So it's not super straightforward. But the difference here is that this type of object implements the copy trait, which means that when you do an assignment, it gets a copy. And so we're still okay with our single ownership rules at this point, because after we do this, there are effectively 2 of them now. One is owned by S and one is owned by T. Whereas when we were doing the string object like that doesn't implement the copy trait. So therefore, the assignment didn't do a copy, it moved it instead. So there's a piece of this system called the borrow checker that enforces all this, and the game is fighting with the borrow checker, they call it. So when you start learning how to program in Rust, this stuff happens all the time because you're used to these programming patterns where you have multiple references, so why not? And then the compiler's like, no, you can't do that. You're like, well, what the hell can I do now? Because my patterns all assume I can do this. So you have to learn kind of a different paradigm of getting your way through problems, yeah.
With the object reassignment, is it actually moving the object to a different point in memory, or is it just removing the pointer from one?
I'm assuming that it doesn't, just because I don't think it has to, and it would take time to do that. So I think the compiler is just, when it's building, it's just got a table, and it's like, hey, this is now the symbol that refers to that object.
When you copy something, like a copy trait literally means that you can make a byte for byte copy of something, but a string reference is really just a pointer, so all you're doing is copying a pointer. To a static thing in memory, yeah.
My type hinting when I did just a bare string said instead of it's a string, it's a pointer to a string, an str object.
Okay.
So, I don't know.
Yeah, because I think the type isn't it a string reference when you have a bare string like that?
Yeah, some Ruby level shit.
Yeah.
Roar.
The infinite amount shit is similar to like C++'s unique pointers.
It's extremely similar to that.
String is just like C++ string, like when you use string from, you're heap allocating.
So I think the main difference between this and the unique pointers in C++ is that unique pointer error messages suck, and these are pretty good. I think that's the main difference.
Well, and also if you move them, it'll let you use the empty shell and crash.
If you do
if you move a unique pointer in C++, it'll let you use the thing you moved and crash. It doesn't protect you like Rust does.
Yeah. On that front, like, because Rust is supposedly all memory safe like this, it should never segfault. Like, it should never crash due to a memory error. And I've seen that happen one time, which blew my mind. I was like, what just happened? But I was calling a Rust library that was wrapping a C library, and the C library crashed, is what happened. So
I've only seen it once.
We're still good.
Pretty impressive.
Yeah.
I think if I remember right, internally the unique pointer in C++ just changes the pointer to something, and it overloads. I want to say it overloads something so that when an assignment happens, it just sets the reference to null internally, and the assignment goes elsewhere.
All right, I got one more example here of moving stuff around. I'm just going to make a copy of this thing.
So you can do pointers.
So you can do pointers, but the uniqueness rule is still enforced. Like that, the rules. And I'm kind of talking out my ass now because I'm at the edge of my knowledge. Usually when I'm programming in Rust, I like to be honest.
That's like
thanks for the disclaimer.
Yeah. So sometimes you have to dereference, and I can't remember when. So it comes up sometimes with references to objects. So there are pointers floating around, of course, but
just sounds like where you want to go.
Yeah, I'm sure. So let's do another example here. I've got my string again, I print val s, and that prints out the value. This is fine as it is right now, but if I add this, then we're going to get another borrow checker error. And the reason is, kind of like most languages, if you think about the way parameters get assigned values, that's as if by assignment, right? This parameter s up here is going to be assigned whatever argument we pass in. And so that assignment is also like a movement. So the ownership of this object transfers from this S to that S up there. So now it's owned by this thing. And if we were to try to use it again down here, it would fail because this S down here is no longer the owner. So now what the hell? We can't pass anything to functions and never use it again? Is that the rule? How can we fix this thing? So if I do this and we do a build, we should get that error about, hey, this parameter takes ownership of the value. Do you want to clone? It's always like, hey, make a copy of this. Make a copy and solve all your problems. But there's a better way to do this. Actually, I'm going to add this quick anti-pattern here. You could do something like this and something like this, and that would pass ownership back, but that's horrific. Nobody wants to do that, and you don't have to, thankfully. What you can do is you can say that S is a reference to a string, and I can pass these in instead.
Oh.
And now we're happy again. So we say at this point that this function is borrowing this value. So the ownership stays here, but temporarily, while that S is alive up there, it will be able to borrow that value. Now, there are all kinds of rules about this because we have that rule about you can only have one owner at once, right? And we don't want to violate that rule. So there are rules about how you can borrow. And the general rule is any number of things can borrow an object immutably. If you're going to borrow it read-only, like everybody in the room, we can all borrow the object read-only, because that's not going to be a problem. But if anyone wants to borrow it mutably, like they want to be able to change it, only one entity can borrow it mutably at a time, and nobody else can borrow it at all. So there's some more rules in there about borrowing, but.
So is there a mutex pattern then for Rust, where you're going to lock an object? Or?
It does have that kind of support. If you want to do that kind of, no. Rust also has some async support if you want to do asynchronous stuff, and it also has message passing support like Go does. So if you want to do shared nothing type multi-threading, that's also an option, so you don't have to lock anything.
So when you say only one thing can borrow that at a time, how does that work with, say, nesting then? Does that one thing get passed down if you have something nested underneath that and you hand it off again?
Like if you have another function,
yeah,
and you pass in the borrowed thing again.
Something like that, right? Like, does it get passed all the way down, and then
yeah.
Does it get weird if you try and do async down the line there? Is that just
maybe
something you don't
I don't know the answer for that one, but
Probably make it weird.
Yeah,
I mean, sure.
I think the general answer is, could it get weird? Yeah, the answer is yes, probably.
Yeah.
I don't know how.
You have another function underneath that, and then it passes that bar down.
Yeah.
That. Okay.
And the compiler is enforcing all this, so it knows when it's building the code, it knows where the borrows are happening, and it'll stop you. So if you borrowed something immutably a bunch of times and you get way down the bottom, and something tries to borrow it mutably down at the bottom of this giant call chain, the compiler is going to stop you at that point.
And it does have to be handed down mutably all the way down until you want to use it, or?
God, is that true even?
I'm just curious.
Any Rust experts in here?
You can't turn an immutable reference into a mutable reference.
Yeah, yeah.
If you want to use
I didn't think you could.
It has to be mutable all the way down.
All the way down. I thought so too.
From the original owner.
Yeah. And the original object as well has to be declared as mutable. Like, I haven't declared this S as mutable.
That's one
either,
great thing is it has same defaults, immutable by default.
Yeah.
And private by default.
And there have been so many times when I've been building a project where I get that error message. This is immutable. I'm like, oh yeah.
So the least amount of typing gets you the most often correct thing, which is good.
Yeah.
And if you get to that point, it starts throwing things, that means you did something wrong at some point.
Yeah.
Your plan
Yeah.
was wrong, not that the.
Yeah.
You're making it weird. Yeah.
And the compiler's goal is, the compiler wants to prove to itself that your code is correct.
Yeah.
And so it's gonna, if it gets confused at some point and can't prove that, then it's gonna stop you. Which is kind of nice in a compiler, I guess.
Pair programming.
Let's see here. So we talked about borrowing, and the copy trait we kind of mentioned. This is an example that works just fine. 2 is a number that effectively implements the copy trait. So when you do the assignment, T gets to be a copy of that. So no ownership problems there. I have this note here that anything can implement the copy trait if you want, but if you don't, then you can use .clone to make a copy of it.
Can you override copy, like when you're defining the copy trait or implementing that, you can override what happens when you copy an object?
I think so.
Okay.
Yeah.
So you could like copy hello world, but it actually turns into crabs or something like that.
I think that's
Copy usually isn't automatically derived. True.
right, because I've only derived it
You
ever.
can customize.
Yeah, because that's a.
But can you
Copy
can you do
is
your own
really only
copy?
for types where it should be a byte for byte. Like you
Mhm.
4-byte integer, copy. But if it's like some complex nested data structure, you can't copy that.
So you have to do.
You have to only clone.
But you can override the behavior of clone.
You can override the behavior of clone. Yeah.
Because that's just a method on the whatever class. OOP.
Right.
Shenanigans.
And in one of the projects that I worked on early on when I was trying to learn the language, there was a point where I felt like I just worked myself into a corner with my particular borrows and the references I had floating around. And I was trying to avoid using clone for kind of purist reasons or something, but at the end of the day, it was like this 1-byte object or something. I'm like, just copy the object. Like, there's no point. And so I used clone and got out of trouble, and that was that. I'm only going to mention this. Lifetimes. The compiler needs to be aware that if it has a reference to something, the thing that's being referred to is going to live as long as the reference lives. That's how it kind of keeps track of stuff. Like, I'm referring to this thing, so what if I make a reference to an object, and then that object falls out of scope, but I still have a reference? Now that object is gone, but I've still got a reference to it. That is not allowed. We can't do that at all. So the Rust compiler is really good at figuring this stuff out for the most part, but occasionally it can't figure it out. There are some cases that are ambiguous to it, and you have to give it a little bit of help. And so look that up in the book and get more information on how that works. It's too much to talk about at this point, but if I was going to say what are the 2 sticking points of learning Rust, it's the borrow checker and its lifetimes. These are the 2 things that give everybody trouble, largely because other languages, you don't have to deal with this stuff. So, something to look up. Anyway, finally, what are we talking about here? Web frameworks. I thought, how hard is it to write a web server in Rust that we can use to like send out a handful web requests and send out whatever? Do our RESTful API, build it through this. And so I'm like, is there, yeah, exactly. Get this right status code going. I'm like, are there any web frameworks? I'm sure I've only listed like half of them here, or fewer, but I'm like, okay, which of these is the easiest to demo in front of a bunch of people? And it looked like the Actix one was pretty easy to demo. So I went to check that out and see what we can do. It has a website, and you can go look up everything about it, but let me go ahead and start a new project, and we can, let's see, am I in the right place? Yeah. Cargo, new web, we'll call it that. And the first thing I want to do is change one of my dependencies. I have to bring in this dependency right here. And this is going to cause Cargo to go out and locate this package with some version number and get it before I use it. So I'm going to add that to the dependencies section right here of my Cargo file. That doesn't actually install anything yet, of course, but Cargo, first time I build, is going to be like, oh, new dependencies, let's go get all that stuff. So, oops. Made a new project, so I've got my hello world. Let's see here. Add the endpoint handlers. I'm going to start at the beginning, or at the end, depending on how you arrange your functions in your head. What's going on here in this code? We've got a use statement. This is kind of bringing in all these symbols out of this package into the namespace so we can use them. If you've used such things in C++, it's similar. But basically I'm saying, hey, I want to use get and app and HTTP response and HTTP server and all that stuff. I want to use that here without needing to namespace it ahead of time. And HTTP response, yeah, I'm using it right here, in fact. And this is my handler for something. It looks like it's for the get/path, but more on that in a second. So this is the handler, and what we're looking at here is a function called hello that returns an object that implements the responder trait. And it's also an async function, all right? And here's the last line of this function. This might look a little weird to people who aren't used to Ruby or something. This line right here is an expression that is the return value of this function. So the last line of the function, if it doesn't have a semicolon at the end of it, is going to be the return value of the function, effectively in this case. So this is getting returned. Just imagine a return statement in front of this. That's what I'm getting at. So we returned an HTTP response. That's okay. There's probably a 200 and a cat in there. And then .body, the body of the response is hello world. This weird thing at the top is some of the magic that's coming in from Actix, the web framework. So you can think of this thing as kind of like a function decorator in this case, but we are saying, hey, whenever somebody does a get on the /path, this is the handler that's going to happen for that. And so there's like a post and so on for the different request types. So that's part of it. Let me steal all this code and paste it in here. Just once probably is enough. Outside of my main is probably even better. There we go. And then we've got to add the stuff to the main. And that's that. So main, another async function at this point, is going to return a result, a standard IO result, which is going to be like okay or some error. And then more boilerplate here. We're going to make a new HTTP server, and then we have this syntax. Anybody care for a guess on what's going on here?
Confusion? Stood IO result.
Confusion? It is confusion. What else?
A lambda expression.
Yeah, it's a lambda expression. This is an anonymous function in here. The parameters would go in between these pipe symbols if it had any. It doesn't have any. So we got this anonymous function here, and when it runs, it's going to make a new app service, new app, and it's going to call .service with hello, that function that we wrote earlier. And so that's kind of like registering that function as something we want to do. And then when we get that new HTTP server back, we're going to bind it to localhost on that port, and then we're going to run it, and then we call await, which is how you get an async function to actually execute at the end of the day. There's that question mark in here. That's something that you also see, I think, in Ruby. Sorry to keep bringing Ruby up, geez. That's basically if there's a failure at this point, we'll bail out and exit with a bad result. So let me copy this stuff over, and we'll take a look at the server in all its glory. Again, we've got this at the front of this function here. Main is async, so somebody has to await it, so I'm assuming that there's some code behind this somewhere that actually awaits that to make it happen. But that's the extent of it. And if we wanted more endpoints, we'd put them up here. HTTP response has all kinds of stuff for changing status codes and the types of the response that's coming back. If it's application JSON or whatever, you could change that stuff here. But let's see if it runs, actually. That would be nice to know. Cargo run. So first of all, one time only, we got to download every single dependency that this web server program has. So everybody audit this real quick.
Tokyo.
Sneak and do it.
If you want to do Rust, get yourself a really fast computer.
Yeah, the Rust compiler is known as being the fastest in the world. That's false. The Rust compiler is known as having a lot of trouble being fast. So if you were looking to escape C++ because of build times,
Have fun. Because it has a really, really good package manager, it's kind of like JavaScript, and the ecosystem is like oriented around micro libraries. So it has hundreds and hundreds of dependencies for things, which is good and bad.
Which is good and bad. The double-edged sword. Everybody remembers pad left, right? So
basically what you're saying is it's Gen 2, but for programming languages.
Yeah, kind of.
Did you just reference JavaScript as having a good package manager?
Well, it pioneered a lot of things. Like,
so
yeah.
Rust in the right context that was extremely fast.
Yes.
So blockchain makes the most use of that language.
Yes.
that's true. There's a lot of it. And it's also because it's
The correctness.
the
more so,
correctness
yeah.
is a big deal. Like with this language, more than any other language, I've had programs run correctly on the first try.
You don't want
it's
hackers
kind of amazing.
constantly swinging it, at your program like it's a giant pinata.
Yeah.
Knocking money out of it, then you need it to be right.
Yeah, like if you're going to write it in C or C++, proving that you don't have a memory issue is like kind of tough. So
You only get to launch once, and then it's public forever.
yeah, and if you're like managing some kind of crypto and you have billions of dollars, like
I mean, it's a language that was designed to be a JavaScript sandbox for the world.
wow, JavaScript sandbox for the world.
Okay, was JavaScript?
All right, this says it's running, so let me just pop over here with my other glasses so I can see what I'm doing. To localhost, what do I call it, 8086? Hello world.
Yay.
Live demo.
First
try.
Only one thing didn't go right.
Wow.
Is there a CPOT method?
Yeah, can we return?
There better be. I mean, I haven't exhaustively searched the docs, but
418.
so it seemed to me like the thing I like about frameworks like this is that it's very it's declarative and explicit. You're like, I want to wait on get requests from this thing. I want exactly this to go back. And in one of the classes, some students have been in this class with me. We use Ruby on Rails, which is extremely popular and powerful. God bless it. But it's also it has a lot of magic stuff that happens behind your back. If you name things the right thing, then it works well, and it hooks all this stuff up for you, so you barely have to type anything. And I'm sure a lot of developers love that. I mean, you can get a lot of stuff done really fast, but my brain tends to work with, I want to exactly hook up this thing to this thing, and if I don't say it, then I don't want it done, and I like this framework for that reason. I'm sure there are other frameworks that are more Rails-like. I just didn't explore them all. So, I think that's all I got.
Nice.
Any other questions about Rust that I may or may not be able to answer?
Lifetimes.
I'm not going to talk about lifetime.
Who tends to like this language? Like what type of programmers?
So I can only speak for myself. I don't know if anybody else wants to pipe up.
So,
But I'm low-level programmer,
Real quick,
so I like
Rust is also a cult, in case you don't know.
Yeah.
Just warning.
So I like programming in C a lot. I mean, I would never use it in production for a new thing unless it was the right language for the job, which it rarely is anymore. But I admire that it's low level and I have fun doing that. And I didn't like C++ because it was like a lot of stuff got bolted onto C and it turned into this giant thing that still had all the same problems and then some. And then Rust came along and it kind of is like, hey, let's get rid of some of those issues that C++ has, but still keep that low-level ability and that low-level feel. And it's compiled and it doesn't have a garbage collector, so that made me feel right at home in a bunch of ways. So I think people like me probably would like it, although the first couple weeks when I was messing with it, there was a lot of profanity. And I couldn't tell if I liked it or not, but I was like, well, I've been programming for like 3 weeks, and I keep going back to it. So either just I'm a total masochist or I actually like this thing, and it took a while, but the more I programmed, the happier I got. So
I was gonna say, aren't there people making like full-blown operating systems out of Rust? Like, isn't Rust capable of doing that?
Absolutely.
So I guess if you're an OS developer, that's one way you can use it.
Yeah, and on that front, well, there are a couple things here. One is there's an operating system which I think is called XV6, which is a classroom operating system. It's for learning about operating systems, and it's written in C, but somebody has ported that to Rust. So there's an XV6 version of Rust, so an operating system that you can use for learning that's written in that. And also Linux, you probably heard, now Linux has device driver support for Rust, so you can write device drivers, which is a perfect place, I think, for...
There's a great website called memorysafety.org, and it's a funded initiative by a lot of big tech and the Internet Safety Research Group, and they're building a lot of core internet infrastructure in Rust. So they're sponsoring Brussels, which is a pure Rust implementation of TLS. So I'd say in 5 years, very few people are going to be using OpenSSL. So they're like curl and all those tools now have a backend using Brussels. There's secure DNS. Cloudflare just dumped like their custom Nginx proxy thing for a streamlined thing. So all the stuff that goes through Cloudflare is now written in Rust. So there's some people building like really big internet infrastructure stuff in Rust.
Yeah, I think that memory safety is it's just so nice to have that extra level of security and not need to worry about that kind of stuff. And as anybody who's taken any classes with me where you've done C programming, like you're all familiar with core dumps and segmentation faults, like they just happen all the friggin' time, and it's kind of nice to have the compiler tell you ahead of time, you can't do that because it's not safe.
Anyone doing interpreters or VMs for other languages, like if you were to write a JVM from scratch in 2024, Rust would be like a natural thing to write a JVM in, for instance, instead of C or C++, or people are like Dino is a Node runtime.
Well, now the most recent JVMs for the last several versions have been written in Java. It's been self-bootstrapped for a while.
And if I can go back in time a little bit to the Flash days, there's somebody in Rust, somebody wrote a thing called Ruffle. It's written in Rust, and it's a drop-in replacement that runs in WASM. So you can, if you've got old Flash apps that you can no longer use anymore, check out Ruffle. Pretty good.
It seems like the whole memory safety thing came full circle then, because then you can do something cool that opens you up to a whole new world of hurt.
Yeah.
A, writing a JVM in Java sounds like a circular reference and a horrible idea. B, does Rust do anything, like any other sort of like safety checks, like balance checks and other memory management stuff other than just pointers?
Yeah, the balance checks are like built in, like with arrays, but I would say the other big thing that Beej had time to talk on was like those constructs like copy and clone that protect you with references. It has similar built-in constructs for multi-threading. So you almost have like multi-threading correctness. If you've ever written a program in Java and gotten like concurrent access exception, blah, 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 like that isn't a thing in Rust because the compiler is concurrency aware. That when you pass something from one thread to another, it knows that it's safe to do so with that type. So
and
you
it's
have a
all
lot of confidence when you write something like a multi-threaded web server.
It's all part of the borrow checker, right? I haven't written much multi-threaded
It's not really
code,
borrow
but
checker. It comes down to this sync and send traits and how they operate with threads.
But if you have, even with threads, you won't have multiple threads accessing the same thing at once, right? Because at some point, it's not like in C where you launch a new thread and you end up with two variables that point.
Or you could just pass a pointer to something on your stack to another thread and it blows up sometime later. No, it protects you from all of that. And then you have those types like reference counted smart pointers, like a shared pointer in C is like an arc in Rust.
Yeah.
But it's built into the language, so it makes multi-threading like you can really have confidence that you haven't done something dumb.
Yeah. So we're not using Rust in Computer Science 444 where we're talking about multi-threading right now, because we have to have all that experience of doing dumb things. And,
I'd rather not.
Yeah.
We can just talk about it. And
feel the pain like the rest of us did.
Yeah.
You have to learn the pain of bad programming in order to become a better programmer.
Builds character.
Back in my day, we didn't have no borrow checkers.
Yeah, it's like the engineering equivalent of camping and changing your own oil.
Yeah. You talk about strings some, but I'm a little bit curious about arrays. Like, are they dynamically allocated? Like, how's that actually look under the hood?
So in real life, there definitely are arrays, and you can make an array of a fixed size. In real life, there's a vector type that is really commonly used, which will grow and shrink. Will it shrink? I'm not sure if it shrinks. It probably does. It'll grow as you need it to grow, and it acts like an array.
The actual memory management of that behind the scenes.
Rust will take care of all that stuff for you, so that you don't have to worry about accidentally using something after you've.
Yeah, you can do like statically sized arrays if you're on a microcontroller and it's all stack allocated, or you can do heap allocated arrays.
Yeah.
And so when we're saying that we can't make this segfault, like if you statically assign an array and then run off the end of it, like can you force one?
You can have errors do a couple of different things that aren't covered by the memory safety gauge. You can have a stack overflow.
Yeah.
So if you throw a 2 million integer size array onto the stack, you'll get a panic.
So you can make
you get a panic which will unwind the stack. It won't corrupt memory, but you can overflow the stack. You can add a memory on the heap.
Yeah.
But the one thing you can't do is take a reference to some place in memory and have it not be valid. Like that's the guarantee.
Yep.
So meaning you can't have a vulnerability where you would run off the end of your allocated memory into something else.
Right, stuff like OpenSSL's Heartbleed from 5 or 6 years ago is like the perfect example of
That's
stuff.
exactly what I was
No
thinking.
buffer overflows, no use after freeze, just all those typical C vulns, just memory vulns don't exist.
Huh.
Sweet.
Yeah. All right. Thanks, everybody.
All right, so feel free to socialize for a little bit. We'll 8:30? 9. We're gonna go till 9 tonight, so feel free to socialize till 9. Do not forget Cloud Beers next Thursday, and do not forget Caroline's thing next Wednesday, and do not forget my stupid thing, Sisters, on Saturday. If you want to come watch me make a fool of myself.
Yeah. Thank you all so much for coming. There's unfortunately no more tacos left. There's
Yeah,
no more beer left.
that's why I didn't talk to you.
Yeah. I think we nailed it on the right amount of food. What's that?
Thank you, that was great.
I'm glad. All right. Thank you so much. Yeah.